So I got cut off there. So just to explain, so this is how I found x1, so 0.75 times 1068, and this is how I found x2, and then you had your n1 and n2. We found the p-value of 0.010, so that's how we got rid of C and D, because that's not the correct p-value. But remember that alpha is equal to 0.05. So both of these say since the p-value is less than or equal to alpha. Okay, so that's good. But if it's less than or equal to alpha, you are able to reject the null hypothesis, which means that there is sufficient evidence of a difference in those two proportions. That's how I got letter A. Okay, for the next 4 questions, we have a recent study considered if dogs could be trained to detect whether a person has lung cancer or breast cancer by smelling the subject's breath. Once trained, dogs were tested using 5 breath samples, one of which came from a cancer patient. Is the correctly detected rate higher than random guessing? Okay, so our hypotheses is that the patient does not have cancer, and the alternative is that the patient does have cancer. So now we're going to talk about errors. So for number 64, remember we are going to talk about a type 1 error, which means that you have sufficient evidence for HA, but it's HO. Okay, so you guys have to remember that. You had enough evidence to say HA, but it's not HA. So that means in this problem, we had enough evidence to say that the patient had cancer. So the dog detects cancer. Okay, so we're going to get rid of B and D because it says the dog does not detect cancer. That's not true. The dog did, but really the patient does not have cancer. So that's letter A. 64 is letter A. Okay, then 65, what is a possible consequence of making a type 1 error in this situation? This, you're just trying to figure out what makes the most sense. So 65 says that a cause and effect relationship between dogs and cancer detection has been established. So just think about it. If the dog says they have cancer when in fact they do not, that's definitely not going to happen, okay? The patient will continue to have cancer that is undetected. Well, the patient doesn't have cancer, so that's not true. The patient will undergo treatment, that's not necessary. That's definitely true, right? If the dog's trying to say the patient has cancer, but they really don't, they're going to get treatment they don't need. So it's got to be letter C, because letter D is saying there's no consequence, which is not true. Most errors are going to have consequences. And then 66, select the appropriate context for a type 2 error. So remember, a type 2 error is when you have insufficient evidence for HA, but it is HA. So you didn't get enough evidence to say HA, but it is. So that means you didn't have enough evidence to say they had cancer. So the dog did not detect cancer, so it's got to be B or D. But really, they did. So the dog does not detect cancer when in fact the patient does have cancer. So letter D. And then on the next page, page 10, what is a possible consequence of making this type 2 error? Well, think about it. If they're trying to say, no, you don't have cancer, but really you do, that means you're going to have cancer and not do anything about it. When if you treat cancer earlier, you might be able to prevent more, like it progressing even more. So that would definitely be a consequence. Okay, 68. Students investigating the packaging of Ruffles potato chips labeled 28.3 grams, randomly selected 50 bags, and found a mean weight of 28.1 grams with a standard deviation of 1.4 grams. Assuming the weights are normally distributed, so that's good, that means we have an approximately normal distribution, what's the 90% confidence interval? So we've done some confidence interval problems so far in this review, but now we're talking about the mean weight. So remember that when you go about calculating a confidence interval with the mean weight, you're going to go to stat test still, but instead of going to letter A or B for one proportion z int or two proportion z int, this is going to be means, which are t values. So you're just going to go to t interval. Okay, So a T interval, number 8, they ask if you have data or statistics, which we have statistics. They did not list out the data for us. So X bar is your sample mean. So they got a sample mean of 28.1. Then SX is your sample standard deviation, so 1.4. The sample size is 50 bags, and we're calculating this at the 90% confidence level, so 0.9. Once you type that in, we get the confidence interval of 27.768 to 28.432. That's how I get letter C. So remember, in that menu, you're going to go to T interval because now you're basing it off of T scores, not Z scores, when we deal with means. 69, a consumer group reports that a 90% confidence interval for the mean fat content of chicken nuggets from a fast food restaurant is given. So they calculate the confidence interval for us. They want to know the margin of error and the point estimate for the mean fat content of, or for the sample of 30 chicken nuggets. So we have margin of errors and we have X bars. Remember the point estimate, AKA in this case, X bar, is just the middle. So I would just do 15.72 plus 17.28 and divide by 2. So doing that, I get 16.5, which means it has to be B or C. Then your margin of error is how much you go up or down from that. So once I find that value, I could just do 17.28 minus the 16.5 and find out that I go up 0.78 and down 0.78. Remember, you have a margin of error. So remember when you have a confidence interval, if this is X bar, margin of error is up and down. Okay, it's not the whole thing. Letter C. Okay, number 70. For a random sample from a skewed population, for which of the following sample sizes would the sampling distribution of X bar be closest to normal in shape? So remember, anytime that our sample size is greater than or equal to 30, we can call that an approximately normal distribution. So the only one that meets this criteria is letter D. Number 71, which of the following conditions would indicate the sampling distribution of a sampling mean is approximately normal? So once again, we just talked about that it has to be large, greater than or equal to 30. Then we also said that the next one says the population distribution is normal or approximately normal. If they tell you the population is normal, any sample from that you can assume is approximately normal. That's great. And then the box plot of the sampling or of the sample data is approximately symmetrical with no outliers. That would also prove that we have an approximately normal sampling distribution. Letter D. So all of those would be ways. They probably won't show you all ways within one problem, right? You would pick out which one is the most appropriate. Then 72, each individual in a random sample of 50 internet users was asked how many minutes he or she spends online in a typical day. The data was then used to construct a 99% confidence interval for the mean number of minutes spent online in a typical day for all internet users. The confidence interval was 800 to 200 minutes per day. So which of the following is a correct interpretation of that confidence interval? So when you interpret your confidence interval, you're going to say I am or we are at your percent confidence level. So I am or we are 99% confident. And remember, it's that the population mean. So right away I can get rid of B because they say sample mean. That's definitely not true. It has to be the population mean. Number of minutes spent online in a typical day is between 80 and 200. Okay, we're not talking about what percent chance is going to happen or that 99% of the people will happen. We're just that percent confident that the population mean would fall between those two values. So let's see where we're at with time. That's about it. So we'll continue on page 11 in the next video.